Hey PStats, Mr. Zmudio here. Lesson 1.8, comparing histograms of distributions. We're going to continue last lesson where we left off on talking about distributions. We mentioned that when describing distributions, we would like to mention the shape, the center, the spread, and then any unusual features. For the shape, we mentioned how many modes. So is it unimodal? Is it bimodal? And remember, the modes are like the peaks. Or is it uniform? And then we also have how symmetric is it? Or is it skewed? So this should all be review. The centers, we talked about means, or we can use median. The center of the distribution will either be the mean or the median. Sometimes one is better than the other. Remember, medians are better if there are outliers. Means are better if the data is symmetric. All right, with spread, we can look at standard deviation, and that's usually paired with means. And if you mention the median, a good thing to mention would be the range or the IQR. Typically, mean is paired with range and IQR, and means is paired with standard deviation. This is all review, and then unusual features. We also spoke about outliers or possible outliers and any gaps in data. This lesson we're going to be talking about more than one distribution. So here's our first example. I wouldn't worry about copying this down in your notes. Just copy the key parts of today's lesson, which I think are up here, and we've already spoken about these before. So really right now, just pay attention. In this picture, we have two different cities. We have Portland and Minneapolis, and we are looking at the temperature during the month of January. So this histogram shows us for Portland that we had 8 days where the temperature in Portland was between 1 degree and 4 degrees. And then we had 12 days where the temperature was between 4 and 7 degrees Celsius, and so on. And in Minneapolis over here, we can see that we had 1 day where it was between -20 and -17 degrees Celsius, and then so on. So pretty different distributions here. So let's talk about the two compared to each other. With histogram specifically, I like to draw an outline of the shape, and to me that just tells me, gives me a better picture of what the distribution looks like. So in terms of shape, what can we say about Portland? Well, we can say that this one's unimodal. Right, it's got one mode at the top there. Now, is it symmetric? Yeah, I would say it's pretty symmetric. Roughly symmetric, we'll say. It's unimodal, roughly symmetric. Whereas this shape, it also only has like one mode, one peak. So it's also unimodal. But this one's a little more stretched out to the left. So we can say this one is skewed left. And the reason it's skewed left is because of these really, really low values, possibly outliers. And what these outliers do is they stretch the data distribution in this direction. All right, so the shapes are pretty different for these two distributions. Now let's talk about the center. Now for the center, we've mentioned in the past that we can use mean and median. Now what's tough with histograms is that we don't have all the individual values. So you can't actually calculate the mean or the median just by looking at this data distribution. So for center, with histograms, it's okay to eyeball where the center is roughly for these distributions. So looking at Portland, we can see that the center for this is probably somewhere in between 7, maybe 5, 6, or 7. So we can say the center is about 7 degrees Celsius, where the center for Minneapolis might be somewhere around about -5 degrees Celsius. And I'm saying the center there because it looks like about half the data is above it and half is below it. It's kind of the middle point. Alright, so we have the shape there. We have the center. We can see that the center for Minneapolis is a little colder, right? We have it -5 degrees, where the center over here is at 7 degrees Celsius. And then the kind of last thing, shape, center, spread. Now for spread, we had a few different terms I've mentioned: standard deviation, range, and interquartile range. Now 2 of those you can't actually calculate because you don't have the numbers. You can't calculate standard deviation, and you can't calculate interquartile range. But what you do have is a range of values. And remember, spread, you're basically looking at how spread out was the data, how different was the data. And looking at just Portland, the range of values, well, it ranged from 1 degree Celsius to 13 degrees Celsius. So we can say we have a range of about 12 degrees Celsius. Right? How did I get 12? 13 minus 1. Where over here from Minneapolis, we can see that we have a much wider range of degrees, a much wider range of temperature. That's why we say spread. This data is way more spread out. There's more variability within the temperatures of each of these days. So for Minneapolis, we have a range of about, well, let me see, we go from 7 to -20. I can do 7 minus -20, or just do 20 plus 7. We have a range of about 27 degrees Celsius. Alright, so shape there, center, spread, and let's see, do we have any unusual features? Well, remember, for unusual features, we're going to be looking at gaps, any gaps in bins, and we don't really have any gaps here. All 4 of these bins are next to each other. And then we're looking at any potential outliers, and this one we didn't say any outliers, and it's pretty symmetric, so none there. I'm just going to write none. Now for Minneapolis, we don't see any gaps in our bins either. We can see that every single one of these bins is touching each other. They're right next to each other. So there's no gaps there. But do we have any possible outliers? And I'm going to say that we do. And the reason that is we mentioned before that this distribution is skewed left, right? We said that that was skewed left because these 2 over here, they seem pretty low in comparison to the other ones. So they might be outliers. So I'm going to say we have 2 possible outliers, and they're between what is this, negative 20 and negative 14 degrees Celsius. I don't know what those actual numbers are going to be, so we just say between negative 20 and negative 14 degrees Celsius. Alright, so when describing distributions, describe the shape, center, spread, and any unusual features. When you actually take the AP test, if you have a question where you're just asked to describe distributions like this, you're actually going to have to write this all out in a sentence format. And we'll get more practice with the sentence format later on in the year. But what that would include is using actual comparison language. So something like that would be like the shape for Portland's distribution is roughly symmetric, while the shape for Minneapolis is somewhat skewed left. And then if I was talking about the center, I would say the center for Minneapolis is about negative 5 degrees, whereas Portland's center is a little higher at 7 degrees Celsius. So using comparison language, like whereas, higher than, or shorter than, lower than, stuff like that. All right, that pretty much covers this lesson, guys. A few questions for you, kind of checking your understanding with these two. And what we have here is two university classes. Here's your first class and here's your second class. And in each of these classes, there's 100 students. And we are looking at how they performed on a test. And we can see that in the bottom here, we have the scores from 70 to 90. Over here, we have scores from 70 to 90 also.